As an engineer, it's easy to let yourself fall into a tunnel vision situation. You spend a lot of time designing something like a board. The first thing you know, that board becomes your whole universe. You're all down there in the components and traces and vias, and you're putting in tiny trombones to balance timing. And then you start to notice the walls closing in on you, and those components start to look kind of sinister and mean, and then you're running across a field trying to get away from this giant power supply monster, and... Sorry, that might have been one of my late project nightmares. Right. Anyway, our tendency to focus in on one thing can cause us to lose sight of the big picture. We're really designing products, not just PCBs. Hi, I'm Amelia Dalton, host of Chalk Talk. Since we are really all designing products, and not just boards, it would be very helpful if our design tools saw the world that way as well. My guest today is Bob Potock of Zuken, and Bob and I are going to talk about elevating your engineering from the board level to the product level. Before we get started, remember to click the link. There you can download a free white paper that further expands on this topic. Welcome, Bob. Thanks so much for joining me again.
Hi, Amelia. Glad to be here. Thank you.
So as an engineer, it's easy to get bogged down in the technology aspect of things, but we're all really just designing a product, right?
Exactly. At the end of the day, we're building and we're selling products.
Yeah.
And the market's become much more competitive because successful companies are now building very competitive products.
Yeah.
They're building products, not just boards anymore.
Mm-hmm.
And the way these companies are competing is changing as well. So a mobile phone isn't just a mobile phone anymore. And
right.
TV is not just a TV anymore. So you have to look at the extended product life cycle. When a new product comes out, there's an initial function.
Yeah.
And that initial function gets optimized over time. So it might get smaller, it might get cheaper, there's going to be design improvements.
Sure.
And then something interesting happens. The functionality expands.
Yeah.
So that a phone becomes a smartphone and a television becomes a smart television. And then another thing happens. The style starts changing.
Yeah.
So now people aren't buying necessarily for functionality, they're buying for looks.
Right.
All these factors have to come into play when you're designing a product.
So if we take our product and we strip off all the plastic, we're going to get down to a PCB most of the time. Let's get down to that PCB level, Bob.
Exactly. Let's talk about Pcb Centric Design, which is most prevalent today.
Okay.
Where the focus is really on the printed circuit board and not the product.
Right.
So the enhancements that are coming out are surface mount enhancements or BGA routing and breakout enhancements or high density interconnect.
Yeah.
But they're single domain. They're not looking at product considerations, cost, weight, size, mechanical. Right. Those are critical elements for a competitive product.
Absolutely.
So from that perspective, PCB Centric Design is beginning to fall behind. It's lacking the product view that contains multiple domain considerations. For instance, the BOM shouldn't be a printed circuit board BOM. It should be a product BOM.
Yeah.
And what a lot of companies are doing today is they're attempting to wrap a PCB-centric design process with software or other tools to try to make it into a product-centric design process.
I see that. So, Bob, why do you think things are changing? Why are we shifting from PCB-centric to product-focused design?
There are a lot of things happening technology-wise that are really impacting the products. And you have to look beyond the printed circuit board technology to really understand that.
Sure.
Here are just a few examples that are really changing the way products compete. System on a chip, touch sensing and display technology, connectivity, plastics and molding. And here's just a few examples on the slide here. The item on the left is actually a thermostat created by Nest. It's a connected thermostat. It's a self-teaching thermostat. Notice the shape. It's circular.
Right.
So here's an example of expanded functionality because now you've taken a thermostat and you've connected it to the internet.
Yeah.
You've also looked at the style aspect of it. It's round. It has an LED display. It's very attractive.
Yeah, it's slick.
It's not your ordinary thermostat that you saw several years ago.
No.
So when you look at each of these technologies, and we're going to go a little bit more in depth, you'll see how each of them has an impact on the product development cycle.
Okay, so Bob, the first thing you mentioned was SoC. Let's dive down into that one a little bit.
I think SoC is probably the most profound change in terms of the way hardware is designed.
Yeah.
What the SoC has done is it really is standardized on different buses, different processor cores, and it allows configuration to be aligned with vertical market requirements.
Right.
That is huge. Another aspect of SoC are the ecosystems that they're creating. So we have vertical market reference designs and boards. So now I can go to Freescale or Intel or TI or NVIDIA and get reference designs for vertical markets, for automotive, for consumer, for networking. And I can get the designs and I can get reference boards.
Right.
Now, when we look at the software ecosystems, we have similar things. I can get the device drivers, I could get the bootloaders, I can get the OS. And I can get off-the-shelf single-board computers that reflect those designs.
Mm-hmm.
So what is this doing to the hardware design process? Well, what it's doing is it's shifting the focus from design and debug to getting the OS running on the new prototypes.
Right.
Because the software is one of the key competitive differentiators and typically the long pole.
Yeah.
So companies are even going to the next step of creating reference platforms that they can extend year over year over year with new technology. Very different way to design hardware than they did a few years ago.
Right. Okay, so you also mentioned touch sensing and display. Wait a second, I gotta update my Facebook status on my smartphone.
Well, touch sensing and display technology is probably one of the most visible and more pervasive technologies that we're seeing. It really changes how the product interacts with you and I, as
sure.
you were talking about Facebook and your phone.
Right.
So we've essentially eliminated mechanical buttons. We've replaced that with touch screens, and now the software is defining the application. So a fairly generic product can be used in a number of different applications. This goes back to the SoC, common hardware platform story. But what's challenging from the design process is now that the lines are blurring between electrical and mechanical. So when you see something like this Panasonic 4K tablet,
Yeah, wow.
it's a beautiful product. It has 4 times the number of pixels that a 1080p display has. But is that display part of the mechanical design, or is
Right.
that part of the electrical?
Yeah.
And when you look at a PCB centric design process, handling that display becomes problematic because it's PCB centric, not product centric.
Okay, now I'm gonna say 3 letters everyone has been waiting for: IoT. Just about everything we design today has to be connected, right, Bob?
Absolutely, and this presentation wouldn't be complete if we didn't talk about IoT.
Of course not.
So we have 26 billion connected devices by 2020.
Wow.
According to Gartner, these
Okay.
are real numbers. And this spans all market segments.
Yeah.
So this brings another challenge to the design process. Let's just say I'm building a thermostat,
Okay.
or I'm building a refrigerator. Do I have to be a Wi-Fi expert? No, I'm a television expert, or
Right.
I'm a refrigerator expert. So this comes back to the SoC story. One of the benefits of the SoC was all that standardization we talked about and all those reference designs we talked about. And now we have block-based design, so I could be designing a thermostat or a television or a refrigerator, and I can basically configure that using SoC technology to get what I need without being an expert in all those different areas.
Right. Okay, so given all of these technology changes, how do we build more competitive products? It seems like there's a whole bunch to juggle here.
It is. And the answer, or the obvious answer, I should say, is that you have to align product requirements with design requirements.
That makes sense, yeah.
It sounds obvious, but it's not so easy in a PCB-centric design process.
Sure.
Because now you have to consider multiple domains. You have to consider your supply chain for cost and availability. You have to look at the electronics from a software performance perspective, from a display perspective,
Yeah.
connectivity, battery life. And then you have the mechanical side, which we referred to as the style earlier.
Yeah.
You now have shapes with complex curves on your products. Weight becomes a factor. The size of your display and the resolution of your display becomes a factor.
Yeah.
And interesting enough, there was a survey done recently by PTC. 73% of the engineers said most critical decisions are made during the concept development process.
Huh, interesting.
So this is the point where products become more competitive.
It sounds like we're really talking about product planning here, right?
Exactly. It's the old what-if analysis.
Yeah.
So let's look at this image right here. We have product requirements on the left. Cost, weight, size, shape, battery life, performance, etc.
Yeah.
We need to move those requirements into a planning process.
Sure.
Remember what I said earlier, that this is nothing more than aligning product requirements with design requirements.
Yeah.
An
okay.
obvious step, but not so obvious in a printed circuit board centric design process. So when we look at the 4 domains that we're looking at right now, cost planning, functional planning, PCB planning, and space planning, they all have to be connected because we need to validate cost targets, weight targets, size targets,
Sure.
and we have to make trade-offs. Will the board fit into the enclosure?
Right, yeah.
Can I hit my cost target with this particular part, or do I need to change out the parts? And if I change out the part, do I compromise functionality?
Sure.
These are all intertwined trade-offs that are best done at the planning phase as opposed to the design phase.
For sure. So, Bob, this really seems a lot bigger than the back of your standard napkin, for instance. So, how is this done today with traditional PCB centric design?
Well, it's done, Amelia, but it's not done very well.
Okay.
And the primary reason for that is the way it's done today is through disconnected processes.
Ah,
So let me give you an example. You might use Visio to draw a functional block diagram. You might use Excel to create a parts list with some cost estimates. You might use Autodesk to design the enclosure.
sure.
But putting it all together in a single product view is nearly impossible. So that's one challenge. The other challenge that PCB-centric design brings is that trade-offs are typically done during the design process in reaction to a problem.
Ah, right.
And that's not a very productive way to do it. So for instance, they are designing along and suddenly realize that the boards will not fit in the enclosure.
Yeah,
Very costly to make that change that far down in the design process.
absolutely.
They also may find that a connector placement is incorrect. Something as small as that could have huge impact on the design process. But the point here is, without a planning process, trade-offs become reactionary. They're
yeah.
not proactive. They're not made because this is the best decision. They're made because this might be the only decision we
Right.
can make. And then the final bullet here, no link between planning phase and design phase, is because those tools are so disconnected, you have to re-enter all that data into your detailed design process.
Right.
So now you've got wasted effort, you've got wasted time, and hopefully you don't introduce any new errors into the design process.
So, Bob, you told us we need to move from PCB centric design to product centric design. How are we going to go about doing that?
Well, let's start talking more about product-centric design and what that really means.
Okay.
So first and foremost, when we get into the product-centric design process, it's a connected process. So when we look at this diagram below, we start with a planning view.
Okay.
And then that's in contrast to a detailed design view. Everybody's familiar with detailed design with schematics and PCB layout, but we want to talk about the planning side of it right now.
Okay.
So one element of the planning view is the logical view or the functional view. So what are the actual components or requirements that are needed by this product? Memory requirements, processor requirements, connectors, buses, things like that.
Okay.
Then that transitions into the physical view. When we start implementing that, what are the ramifications of putting that onto a board? Is that one board? Is that 2 boards? Is it 3 boards? Are all the boards the same shape? Are they different shapes? And so forth. So at this point, we're making some guesses essentially to what the board should look like. And then that's all based on the logical design. Now we factor in the geometric or the space view. Now we're bringing in the enclosure.
Ah,
So now the physical view takes more of a real world perspective, because now those boards, 1, 2, 3, or 4, have to now plug into that enclosure in some orientation that makes sense, that can be manufactured. And then finally, we look at the parametric view, where we want to look at essentially the bill of materials for this design. We want to look at some of the timing constraints, some of the critical aspects of the design, so that we can actually look at not only the functional view, but we can look at the connectivity and put constraints around the connectivity. Once the planning view is done, it should be a very simple transition to detailed design, reusing all the analysis that we did during the planning phase.
Okay, so Bob, let's dive down a little deeper. I want some details here.
Okay, this is our multi-domain planning environment tool. This is called System Planner.
Okay.
And you can see each of the windows is associated to one of those domains that we talked about in the previous slide.
Yeah.
In the upper left, we have our block diagram. In the upper right, we have our multi-board 2D floor planning tool for printed circuit board. In the bottom left, we have a parametric analysis that can be bill of materials, it could be constraints, it could be weight, it could be any number of analysis. And on the bottom right is our physical representation. And notice it's a 3D representation, but it actually have the boards placed in there into the enclosure in the orientation that they would be in the final product, and they're in a 3D view as well.
Nice.
Now, what's really interesting about this and what's powerful about this is all connected. So for instance, if I'm in the 3D mode, looking at the enclosure, my space analysis, and I find that one of the boards don't fit and I want to reshape the board, that shape change will propagate back to the floor planning aspect view, and that is all automatically done dynamically. So one of the powerful aspects of this is I can bring in an engineer associated with each of these domains, and they can work in a very collaborative fashion and making trade-offs in real time and making good decisions, good planning decisions in a proactive manner as opposed to a reactionary manner.
That's cool. Okay, so usually I start off with the logical part of my design. Where do we start?
Okay, let's look at the functional block, which is referencing the logical view.
Okay.
So we talk about functional blocks here. Now, what's interesting about a functional block is it can start out as just an empty block representing some function on my product.
Okay.
I can then incrementally add content to that. So I can just add a bill of materials to that block.
Okay.
Or I can go a step further and I can actually use reuse blocks out of my corporate library.
Ah.
I can copy and paste from a previous design schematic, so I can use a portion of a circuit.
Okay.
So I have a lot of flexibility in defining what's in that logical view, because remember, at this point, I don't have a detailed design. This is not detailed design. I'm
Right.
still looking at the planning aspects of the design. So at this point, I'm constructing functional blocks. What's really important here is I'm also defining connectivity. Okay?
Yeah.
So that the idea here is I can transition from a logical view to a physical view very easily, but I can also transition to a detailed design view as well.
Right.
Two very important concepts for the planning phase.
Okay. So say I'm pretty happy with the logical part of my design and it's time to start laying down some FR4. Where are we going now?
Okay, so now we're going to transition to the physical view.
Great.
And now we're into a multi-board placement and partitioning view.
Okay.
So this is really cool. So what I basically can do is take that functional design, I can partition it up into a number of printed circuit boards.
Okay.
It could be one board, it could be 4 boards, whatever you decide. But again, remember, we're in design exploration and planning. So it may start out that I want to use 3 printed circuit boards.
Uh-huh.
But at this point, based on the functional representation and how that looks in the physical world, I may be able to eliminate a printed circuit board.
Nice.
So starting with 3 boards, I can now reduce it to 2 boards. I've saved a lot of money in terms of manufacturing and cost. Good thing to do. I can also optimize interconnects. So again, if I'm working in multiple boards, it may make sense to put some logic on this board versus that board. I
Right.
can do that analysis right here. And what's very powerful is I can actually extend this to signal integrity analysis. So when I'm looking at that connectivity on a multi-board basis, I can really analyze my signal integrity and my connectivity. So that, again, I'm optimizing it for this board orientation.
That's cool. Okay.
And again, that very important point, I can push that right into the detailed design when I'm done. And the detailed design tool, must be able to support multi-board design as well.
Wow.
One of the key characteristics of product-centric design.
All right, Bob, what do we do with the boards now? We're done? Head to Maui?
Nope,
Good.
not quite yet.
Dang.
Not yet. I know. Soon. At this point, we want to look at the geometrical view, and we want to examine the 3D space requirements.
Sure.
So this is a very key concept within product-centric design, because now we're going to essentially bring in the mechanical side.
Okay, yeah.
So now we need to be able to take that 2D multi-board planning, convert it to 3D, and bring in a 3D enclosure from some mechanical tool.
Okay, sure.
Creo, CATIA, and so forth. Now, what's powerful inside this space planning tool is that I have analysis capabilities. I can bind the boards to a particular orientation within the enclosure. I can change the origin, the orientation, the scale. So I have the ability to move things around to really optimize and test the shape of the printed circuit boards versus the shape of the enclosure.
Right.
What I mentioned earlier, if I need to resize or reshape a printed circuit board, I can do it at this point.
Right.
And those changes are going to propagate throughout the planning tools,
Yeah.
which is extremely powerful. There is no risk of becoming out of sync. Everything automatically stays synchronized. And again, in terms of analysis, as we did in the printed circuit board view, I can analyze the 3D enclosure with the boards in it to look at RF thermal analysis and so forth. So now I'm doing my 3D check, bringing the electrical and mechanical aspects of the product design together.
Cool. Okay, so I guess we're going to eventually need to give some information to manufacturing. Someone is going to need to build this thing, right?
Exactly, and this will be the final step that we talk about in the planning phase. This is the parametric view.
Okay.
And this is where we're going to start extracting out some of the parametric design elements as well as verifying design targets. So we might want to pull out the BOM at a product level versus a board level.
Right.
Okay? That's a very important concept for hitting a cost target. So maybe we want to verify our cost target. Maybe we want to verify our weight target. Those are product concepts that we're going to have to accommodate in the design process. And then another interesting element here that I talked about earlier is that we can start adding constraints to design at the planning phase. So design intent can be communicated to the detailed design process. We don't want to lose that design intent because that was driving a lot of the trade-off decisions that we were making during the planning phase.
Okay, so planning is taken care of. What's next? How do we transition to design?
And that is the next natural step. So at this point, the design team has come together in a planning phase. They've looked at the product requirements. They've translated those into design requirements.
Yep.
They've made the necessary trade-offs. They've hit their product requirement targets.
Good.
And now we're ready to go to detailed design.
All right.
And in a product-centric approach, this is a seamless, painless effort to go from planning to detailed design.
Nice.
Literally, when you look at those 4 modules or 4 views within the planning phase, they all transition into the detailed design tool. So the functional will transition right into the schematic. The PCB planning tool transitions into the PCB design tool. The parametrics transition to procurement or the constraint system. And the mechanical obviously translates right into the MCAD design. So at this point, we have a seamless transition to detailed design. Now we're ready to roll up our sleeves and dig into the details and make this a reality.
All right. So, Bob, walk me through again how product-centric design is different from PCB-centric design like I'm used to.
Okay, so we want to think about product-centric design as the next generation.
Okay.
PCB-centric design is the current generation, and it's been around a long time.
Yeah.
One of the key concepts is that we want to look at product-centric design at the product-level design abstraction.
Right.
That is a critical concept, product-level design abstraction. We can no longer be centered on the printed circuit board.
Yeah.
The next step is to align product requirements with design requirements, and that should be very easy in a product-centric design environment. And it sounds obvious, but in a PCB-centric design environment, that's a very challenging task.
Yeah.
Because we're dealing with multiple domains, and as we've talked about earlier in the presentation, You have to make trade-offs, and you have to hit targets that are based on products.
Right.
Now, given that, there still are some product-centric requirements that go beyond just the planning phase. So for instance, you really need to have the ability to accommodate dispersed design teams, whether they're across the campus or across the country. We have to have good design data management tools, again, to accommodate those dispersed design teams. A component information system is very important for the planning phase for all those targets that we talked about, cost targets, weight targets, and so forth.
Sure.
I need to have a 2D, 3D, single and multi-board PCB design system. Just imagine how difficult it would have been to do PCB planning if I can only look at one board at a time and I had no visibility in the connectivity between those boards.
Right, good luck.
Very painful.
Yeah.
Exactly. Another aspect is the chip package board co-design. This is becoming more important as well. As products become smaller and smaller, the packaging optimization is becoming more critical. So this is another critical piece of the design process. And finally, you need to be able to support the convergence of ECAD and MCAD. They have to coexist, and that kind of goes back to the 2D, 3D multi-board design capability. In a nutshell, that's what we're looking at product design.
All right, Bob, I think it's time to recap this bad boy.
Okay, let's wrap this up. A few concepts I want to leave with you, some walkaways.
Yes.
Successful companies build highly competitive products.
Yeah.
To do that, they really have to operate at the product level design process, not at the printed circuit board.
Sure.
In this day and age, electronics alone are no longer the sole product differentiator. You have to consider shape, cost, color, weight, functionality. They all matter, and they all have to be factored into the process. PCB Centric Design is falling short on today's design needs. It's been around a long time. It's very good at designing printed circuit boards. It's not very good at designing products.
Yeah.
The product-centric design philosophy is a next-generation approach. One of the key concepts is that you align product requirements with design requirements, and that requires a planning phase, a planning capability. You need to be able to make informed product trade-offs with a multi-domain planning capability. They need to be informed early in the design process as opposed to reactionary later in the design process.
Right.
And that transition from planning to detailed design, it needs to be seamless, and it needs to be without any data loss. Push button. That seamless transition from planning to detailed design is very critical because you really want to preserve all the decisions and all the design intent that you created and captured inside the planning phase. You want to make sure that gets to the detailed design phase in an accurate and complete manner.
Sure.
So at the end of the day, we really want to design products and not just boards.
Awesome. Well, it was great speaking with you today, Bob. Thank you so much for joining me.
Thanks, Amelia. I really enjoyed being here, and I'm looking forward to participating in a future Chalk Talk.
All right. Before we go, don't forget to click that link. There you can download a free white paper that further expands on this topic. For Chalk Talks, I'm Amelia Dalton. For more Chalk Talks, check out the EE Journal YouTube channel or the on-demand section of eejournal.com.